Right, year nines, and we had some good hard work last week. I know you submitted lots of good answers, but even amongst the best of you, some of you were confusing the idea of when a quadratic would factorize and when they have solutions, when they have roots, and it's not the same thing. So an attempt to explain that and give you some practice is what's hopefully going to be a short video, okay, with some questions at the end. So I would urge you to check all these on Desmos. This is where I've ripped this page from, Desmos. In fact, when you do the work at the end, check them on Desmos. That's how you're going to find out if you're right or wrong. So I've plotted this graph on Desmos, and you can see the red line on the right hand side of the screen. If we wanted to find the roots of that equation, if we wanted to find where x squared plus 2x take 8 equals 0, this one does factorize, okay? And you would probably write it as this. You'd say that the factors are x plus 4 and x take 2, and they equal 0 when x is minus 4. So that factor gives rise to that solution, that factor gives rise to that solution. And we see that on the graph, we have 2 and minus 4 are where the graph crosses the x-axis. That's what the roots of an equation are, where the graph would cross the x-axis, where y equals 0. Okay, and then even the second one. If I look at the second one here, which I've plotted here, the blue line, and it's on Desmos. If it's got a blue symbol, it's the blue line. If you factorized x squared plus 2x plus 1, hopefully you would get that it's x plus 1 and x plus 1, which is the same as x plus 1 squared, which means there's only one root. This one touches the axis once. It's a repeated root. Okay, yeah, so they both factorize, which gives us the roots. Okay then, what about this one, x squared plus 2x take 5. You can sit and stare at that all you like. You will not find a pair of integers that multiply to give minus 5 and add to give 2. That quadratic expression does not factorize. But when I plotted on the graph, so this is the green one, so the green line there between the red and the blue one, quite clearly, it does cut the x-axis. So the equation x squared plus 2x take 5 does have solutions. Even though it doesn't factorize, it does have solutions. Then you see I've quite neatly, I'm quite proud of myself here, between the first one I've got all the way up to one solution where it's just touching the axis. So I know that I could have picked any number between minus 8 and plus 1 for this next one and got solutions. Okay, so how do we solve a quadratic equation that doesn't factorize? And that's what all this lesson is going to be about, and then tomorrow we'll look back at discriminant again. This is called the quadratic formula. The A, B, and C, the A is the coefficient of the x squared, which is 1 in this case. The B is the coefficient of x in the quadratic, which in this case is plus 2. So minus b goes in as minus 2, b squared goes in as 2 squared. And then the final letter here is a c. And the c is the constant term, the number on its own, which in this case is minus 5. If you into your calculator type minus 2 plus the square root of that divided by 2, you will get 1.449. In fact, you could check you get that now, couldn't you? If you type all that in, but instead of the plus you use a minus, so we've got a plus and a minus, giving us two answers here, two possible answers, you'll get this root. So you can check that. But on the next page, I'm going to go through one from two. I'm going to go through two from the beginning. Okay. So the first thing is, the crucial thing is here. Here was a quadratic which did not factorise, but clearly when you draw the graph, you can see it's got roots. So here are two quadratic equations set to equal 0. So it's important that the right-hand side is 0. And I've written the quadratic formula out for both of them, the quadratic equation, sorry, quadratic formula. So in the first one, a is 2, there's just one x, c is minus 8. So I make minus b becomes minus 1, b squared is 1 squared, which is 1. 4ac is 4 times 2 times minus 8. 4 times 2 times minus 8 is minus 64. But because of the minus here, so it's minus that, plus 64, and you get that as an expression. And you get that when you separate the plus and minus. Type those into your calculator and check whether you get that number, and that number. If you want to go through it again, all you've got to do is pause and rewind it, haven't you? So do that, okay? I don't mind, I'll go through it quickly, but you can just pause it and watch it again. So in this second one, 1x squared, so a is 1. If it's a 2x squared one or a 3x squared one, the value of a changes to 2 or 3 or so on. In this one, it's minus x, so b is minus 1, and at the end there's c is minus 10. So always the same quadratic formula, which you'll have to learn. So it starts with a minus b. B was negative, so minus b is positive. But when you square 1, you still get 1, a positive 1. So whenever you square the b bit, it's always going to be positive after you've squared it. Take 4a minus c gives a plus 41 here. Notice for all the questions so far, in fact all the questions today, what's inside the square root will be positive so that it can be square rooted. And that gives a pair of answers like that. What does that mean for the graph? It means the following. Okay, here's the two graphs. Here's the, I'm just going to rub out the highlighting so we can see all that. That worked well, didn't it? So the first, oh don't worry, my working I've put onto the next page without this on top of it. Okay, so if you want the working to copy down. So that graph is this violety one, and I said the root should be 1.77 and minus 2.27. And look here, so here is that value goes with that point, and that value goes with that point. The two roots we calculated are where the graph crosses the axis, and that's how you're going to check these today. You're going to use the formula for the ones you set, and then you can check them using Desmos. And for the second one, which also did not factorize, the answers were minus 2.7 and 3.7. Okay, so that page, this page you're looking at now is just to show you how the roots of the equation relate to the shape of the graph. And on this very next page are those calculations, same question repeated. So those roots, which on the if you rewind this, you'll see the two graphs again. So this is the quadratic formula. For solving any quadratic. So if a quadratic has a solution or a pair of solutions, this formula will find it. In fact, this formula will tell us whether it has solutions. Right. From the GCSE textbook, I don't know if you can zoom in on that. There are a couple of examples. These are the questions I want to do, but don't panic. On the very next page, we've made them big enough to read. All I want you to check and see is that there should be an equal sign, and that, and I think that, and that. Where the equal signs are not in front of a 0, and there as well, you'll need to rearrange an equation before you solve it. And to check them, let's say you wanted to check your answer to C. Go on Desmos and type in y equals 7x squared plus 12x plus 2 and see where that graph crosses the x-axis, and it should be the same as the roots you get when you use the quadratic formula. Now, the good thing about the quadratic formula is just look it up on the internet and you have it, but write it down in your book once. Oh, it should be on everyone's blackboard. What do I want you to do today? Well, I've done the first 2 questions. There's no reason why you couldn't try those again and see if you get the same answer. There are another 7 there, and then there are a problem solving, a mathematical reasoning one, this is a communication one, and if the first ones were too easy, you can think about how you do those 2. But remember, it's an hour's work. This video is 11 minutes, so by the time you've gone backwards and forwards on it and made your notes, that might be the first 20 minutes. Then you've got 40 minutes to do any of those questions. So you may want to save that page and just print that page. Good luck with those. Oh, and then on Tuesday, we'll go back and look at the discriminant again. Okay, so this lesson is all about, just because it doesn't factorize doesn't mean that it doesn't solve. Okay.